My name is Dal Thornton. I'm the Regional Training Specialist with Garmin International. Today I'm going to go over Panoptix LiveScope. We're going to talk about the features of each transducer, installation, settings, and a few troubleshooting tips. So if you have any questions, please, we'll try to answer them if you can type them in. But if we don't get to them today, we will please send it to marine.training@garmin.com, and we'll get those questions answered in a timely manner. So if everybody's ready, we'll get going. So first, I want to talk about Panoptix. Panoptix was introduced in 2015 It was developed as an all-seeing sonar with the ability to see everything around the boat in real time. So to best explain how Panoptix works, I want to first talk briefly on some common sonar technology on the market today. So most of us have used or are using some type of traditional sonar similar to a dual frequency. Basically, most sonars out there today are dual frequency. They basically shoot a 50 kilohertz and a 200 kilohertz frequency in the water. With CHIRP technology, or the introduction of CHIRP technology, which stands for compressed high-intensity radiated pulse, we now have the ability to scan basically the entire CHIRP frequency between 40 and 230 at one time. When you think about traditional sonar or CHIRP sonar, think of that transducer shooting down into the water column in a cone shape. So the deeper you go, the wider that cone. So if you're in 100 feet of water, you're looking at probably around 20 to 30 foot across the bottom, where if you're in 200 feet of water, you could be looking at anywhere between 40, 60, or even a wider cone across the bottom. When you look at your scanning sonar, like side view and down view, these transducers have a long rectangular element which creates a very thin, wide beam. That's the reason why when you look at these types of transducers, those transducers range between 4 and 10 inches long. When you think of a traditional sonar, or I'm sorry, a side view or down view sonar, think of each beam like a page in a book. The deeper you go, the wider the beam. Also, every beam, sorry, having a little computer glitch right here. Think of each pulse going in the water like a page in a book. So that page will return that image much better, much more detailed. But remember, traditional and side view, technical difficulties here, sorry. But remember, everything you see on the screen is old news. Traditional and side view, you've gone over. So with Panoptix, we introduced phase array technology. This created a multiple concurrent steerable beam in a single ping. So when you're looking at Panoptix, if we're looking at the frequency range, the frequency is 417 kilohertz. This gives us the ability to have live 2D full screen updates in real time. We also have the ability to have an adjustable 3D scanning update every 1 to 4 seconds. So with Panoptix, with the frequency of 417, we basically have a range of 300 feet forward as well as 300 feet down. All Panoptix transducers also have AHRS built into them. That's basically going to compensate. That's basically going to compensate for movement of the boat. Remember, all Panoptix transducers are designed for basically a slow speed. They're designed for trolling, used on a trolling motor or drifting. So this Panoptix was not designed for a go-fast transducer. And when you're hooking up Panoptix, it's pretty simple, and I'll go over a couple of slides a little later. Basically, it plugs into the network port. So let's take a look at Panoptix. Panoptix basically is phased array sonar. That basically emits a steerable beam where we can look forward and aft of the boat and port to starboard. And this is done very easily with our touchscreen units by basically just tapping on the screen. You can actually manipulate the transducer beam or what the transducer looks like in the water just by moving your hand across the screen as we're showing in the bottom picture. The vessel does not have to be moving to create a 3D image. The range from port to starboard on this image is around a little over 100 feet to port and starboard. And this is a feature of the PS30, 31, as well as the PS60. Also, with phased array technology, we can create a steerable beam. We also can create basically a multiple directional sonar beam with a single ping. What that gives us is that every ping provides an entire two-dimensional update showing real position of targets in the port and starboard position. So these are features of the PS30 as well as the PS60. So you're going to get both a live view down feature as well as a real view 3D historical feature. By rotating the array 90 degrees and tilting it up to a 45-degree angle, we now can achieve a forward scanning sonar. So again, every ping provides an entire two-dimensional update showing real position of targets, fish, in front of the vessel, even when the vessel is not moving. So this is a feature of the Panoptix PS31, the 22, as well as the 51. So depending on what transducer you have, it depends on what Panoptix features you have. So you could have real view 3D down, real view 3D forward, real view 3D historical, live view down, as well as live view forward. And again, this is based on which transducer you have. So installing Panoptix is pretty simple. There's basically two cables that come out of the transducer. One plugs straight into the back of the unit through the network port. The other cable plugs in, goes straight to the battery. So if you do run the cable straight to the battery, the transducers basically have a safety mechanism. So with the transducers out of the water, it will shut off. Once you basically put the boat back in the water or deploy the trolling motor, that transducer will start emitting again. I am a big believer in putting a toggle switch in the positive line. I am notorious for putting my boat on the trailer and bringing it home, and an hour later I see that everything's still running. But, you know, these transducers are pretty expensive, so I try to protect them in any way. So I definitely recommend either putting Panoptix on an accessory switch or on a toggle switch. So Panoptix our capabilities are basically on the 7,000, 7,600 units, the 84 and 8,600 units, all the new 1042 and 1242 touches they'll work on. Panoptix will go as far back as the 741. They will also work on the Echo Map 7 and 9 CHIRP, the Plus units, as well as the new Echo Map Ultras 10 and 12. Unfortunately, I know there's still a lot of 4, 5, 6, and 7,000 series models out there, but they do not have the processor to be able to run Panoptix. So let's take a look at some of the transducers and some of their capabilities. So the first one I want to look at is our PS31. That transducer was the first Panoptix that came out. The PS31 had an adjustable forward beam angle. So you could set that transducer up to read 20 degree, 30 degree, up to 40 degrees out in front of the boat. This transducer was a forward-looking transducer only. So you would receive live view forward as well as real view 3D forward. So there were a couple of, you know, we've learned a lot with these transducers. You can see the face on these transducers are pretty wide. So you you know, it wasn't really designed to be mounted on the transom. But also we learned that a 40-degree cone is just a little too wide when you're looking for structure and fish in front of the boat. So we also introduced the PS30 and the PS60. Both of these units are basically going to give you a live down view, a 3D historical view, as well as a 3D down view. The PS30 is a transom mounted transducer. Really great transducer if you're looking for grouper, snapper, or basically any fish in the water column. I'll basically pull up to a spot. If I don't see any fish down there, I'll drop my jig down. If I move the jig around and I can't bring any fish off the bottom, I move on. There are no fish there. The PS60 is our through hole option. 80% of that picture you see is basically the fairing block. The transducer is the same size as the PS30, and it's right in the center there. So if I do have some boats, if you do have a flat spot on the bottom of the boat, you can get away with not using that fairing block. So with the PS30 and the PS60, you get your live view down, real view 3D, historical, and 3D down, no forward scanning option. So the next transducer we actually introduced was the PS22. You can see we made big changes with this transducer. Much narrower, so it cuts through the water better. Mounted on a transom, much better. So if you do have this transducer mounted on the transom, you can have it right alongside another transducer because the frequencies don't interfere. You can run both transducers at the same time, no issues. One big thing that we added to the PS22 is a rotating knob on the side. So before, if you wanted a live view forward and a live view down, you had to go with a PS30 and a PS31 or a PS60. So you're talking about a lot of money. So with that rotatable knob, you can now have live view forward and live view down in the same transducer. So just rotate the knob down, live view down, rotate it forward, and you have live view forward. We also narrowed the beam to 20 degrees, and I'll talk about the importance of that a little later. But we've gone from a 40-degree beam down to a 20-degree beam, and that's kind of the sweet spot. And again, I'll go over that in a couple more slides. I next want to talk about our PS51. The PS51 is our through-hole transducer with premium front view forward-looking sonar. This is what we basically call our collision avoidance Panoptix. So this transducer has a 20-degree forward and a 90-degree down beam angle. And you can see by the center slide how important a 20-degree beam is. If you're trying to come into a cut or come into a channel, if you have a wider beam, like a 40-degree beam, you're going to get false positive returns. So you may be able to get through that cut, but your sonar is going to tell you you can't. So you can see with a 20-degree cone, we definitely have enough room to get through this cut. AHAR's system is built into, again, all Panoptix for stabilization. Again, this transducer has the ability to see 8 to 10 times the water depth up to 300 feet in front of the boat. You know, again, the transducers, Panoptix was designed as a slow trolling fishing transducer, so operations up to 8 knots. The nice thing about the PS51 through hull, if you already have an existing transducer on the boat from another manufacturer or an AMAR DST 800 housing, you can actually pull that transducer up, not have to take the housing out, and the Panoptix PS51 will drop straight down. One of the other nice features about the Panoptix PS51 is we do consider a collision avoidance sonar. So it's really good for sailboats and trawlers and slow-moving boats. So if you look at the picture on the bottom right, you actually can go in and set a front view alarm. So I've got this one set at 10 feet. So basically that that line's going to be green as long as you've got good clean water in front of the boat. As soon as you turn the boat and it sees land or ground, you're going to get an alarm pops up. It's going to turn red, and you're going to see that it's going to tell you basically distance to your shallow area is 119 feet. So this is one of the main reasons the larger boats are going with the PS51 through hull. So if I can get this video to play here, which I don't know if I can, let's see. This is actually going to show you how the PS51 works. We're actually cruising towards this bridge right here, and we can see that we are going to run aground in basically 275 feet. You can actually see the red is actually some of the bridge pilings. So we're actually going to turn the boat, look for the channel. As we're turning the boat, we still are going to run aground in 200 feet. We keep turning the boat till we have good clean water. There we go. We found the channel, and now we can go through. So with the success of Panoptix, we wanted to make the ideal fishing sonar. So to do that, we took the high resolution of side view and clear view, coupled with Panoptix, the live sonar aspects, and we created Panoptix LiveScope sonar. So with that, we came out with the LVS12. So comparison to Panoptix, the big benefits are you get much greater detail to interpret what's on the bottom. So you can see on the right-hand side, we're looking at the same trees that we're looking at on the left-hand screen, but we really can't tell that those are trees. Targets, fish are much easier to see versus structure. It also gives us the ability to track fish and larger fish in schools of fish and bait. Targets also are very close to their actual size in LiveScope. So if you see a 2 or 3 foot fish in LiveScope, that's a 2 or 3 foot fish. So Panoptix LiveScopes is a system. It comes with the LVS32 and the GLS10 LiveScope black box. LiveScope has a total of 6 sonar beams generated by 3 arrays. As we talked about, Panoptix has a frequency of 417. The frequency of LiveScope is 530 through 1100. It's using all these frequencies. The beam width is 20 degrees forward by 135 degrees down. It also has the AHAR system built in. Think of that as similar to camera stabilization. So no matter what the boat's doing, you're going to get a good picture. It also has traditional and clear view sonar built into the transducer. So installing LiveScope is a little different than Panoptix. Basically, you're going to plug the transducer into the GLS10 sonar modular. The sonar modular will then connect through the network port into your chart plotter. So the GLS10 does need to be powered, so you do need to run it to the battery or a battery switch. Again, I recommend running it into a toggle switch. Just make sure you turn this box off when you get off the boat. We also introduced the LVS through hull back in February. You know, LiveScope was designed as a freshwater inland product, but a lot of the coastal boaters wanted to use the ability of LiveScope. So the through hull was introduced in February. It comes with a stainless steel stem and a fairing block. We also added a stem extender. We found out with the Panoptix PS51 that transducer would not fit on some of the larger, thicker hull boats. So with the new through hull LVS32, we added a stem extender, which you can see without the extender, you can fit hulls up to 2.3 inches. With the extender, they can go through hulls of a little over 7.5 inches. So with Panoptix LiveScope, you're going to get several views. This is live view down. You can see these are all fish moving in the water column. So you have the ability to actually drop your jig down, follow those fish. Again, when I pull up to a spot, when I drop my jig down, if I don't see fish coming up to strike the bait, I move on. This is live view forward. And again, if I can get my presentation to play. There we go. You're going to see we've got a couple of trees about 15 to 20 feet in front of the boat. And then we have some fish, looks like a school of bait hovering over those trees, probably brim or crappie. So again, as you turn that transducer, you can locate structure as well as fish. You can see there those fish are starting to move off that tree. Also, I think everybody knows what this is. These are a couple of tarpon swimming around, basically 10 to 15 feet in front of the boat. They're swimming around some bait. And again, the closer those fish are, the better the detail is. You can see those tarpon are probably about 4 to 6 feet long. So that's one of the benefits of LiveScope versus Panoptix. So like I said before, with Panoptix, you get LiveScope, but you also have traditional and clear view sonar built in. The frequency is based on the middle downward-most facing beam, so you're probably looking at around a 530 to a 600 frequency range, but that's available on the LVS12 and a new Panoptix LiveScope transducer, the LVS12, which I'll talk about in a minute. So let's talk about the importance of the 20-degree beam. Panoptix LiveScope covers 20 degrees forward and basically 135 degrees down. So if the transducer is mounted on the transom of the boat or your trolling motor, you are going to get below the boat as well, and in some cases in back of the boat. When we had a 40-degree beam with our first Panoptix, we found that when you see fish or structure on your screen, it wasn't necessarily in front of the boat. So if you're looking 60 feet out, you basically have a 60-foot beam left to right. So that fish could be anywhere in that beam. Where on a 20-degree beam, we basically, when you see that fish or that structure in front of you, you know you're within probably 10 to 20 feet of that fish. So when you make a cast, you'll be able to see your lure in the water and see if you get a reaction from the fish. So a 20-degree cone is very important. Again, the maximum range of Panoptix LiveScope is 200 feet forward and 200 feet down, with a frequency range of 530 through 1100. So, with Panoptix LiveScope, all your mounting options are included in the box. So, when you get your LiveScope, you can mount it on the barrel of the trolling motor, the shaft of the trolling motor, or the transom. The transom mount bracket comes in the box. We recommend, please do not use zip ties to secure the cable to the trolling motor. We found that may cause damage to the cable. I recommend definitely using waterproof electrical tape. Also, just above the cable, because you are going to rotate this transducer forward and down, leave enough slack in the cable for that adjustment. I just got off a boat last week where the guy clearly used zip ties way too tight. I could tell he was crushing the cable, and they were so tight he left no slack, and when I tried to put the transducer in the down position, it wouldn't go. So I had to cut all those zip ties off just to turn the transducer into the down position. Oh, sorry. So the next two slides are probably the two most important when you're mounting the transducer. It's critical that you mount the transducer, the LiveScope transducer, in the correct orientation on your trolling motor. So you need to decide if you're mounting your trolling motor, if you're mounting the transducer on the port side of the trolling motor or the starboard side of the trolling motor. So the transducer, when that trolling motor is laid down in the boat, that transducer needs to be on the top side, okay? So you can clearly see from picture 1 to picture 3, Both are pointing forward, but the transducer is in a complete different orientation. Okay, so please read your owner's manual and the instruction manual, and make sure you mount the transducer on the barrel in the correct procedure, or in the correct orientation. As well with mounting it on the shaft, make sure if you put it on the starboard side versus the port side, you can see from slide 1 and 3 that the orientation is completely different. The down is the same, but the forward view is completely different. And that's probably one of the number one things I see when I get on the customer's boat and they tell me they're not seeing forward. I look at the transducer and I can tell you they pointed it in the wrong direction. And again, please use waterproof tape to secure the transducer cable to the trolling motor. The other very important thing you need to remember when you're mounting the transducer to the shaft, and I would say probably 80% of the people out there using Panoptix right now are mounting it to the shaft. That bracket has a little arrow on it. That arrow needs to be pointed in the up direction. That bracket has about an 8-degree cant to it, and that cant is designed so that transducer will miss the barrel of the trolling motor. So if you don't put that on the right way, then you're going to have interference from the barrel of the trolling motor on your transducer if it's mounted on the shaft. So make sure that arrow is in the up direction so you get that correct cant and that LiveScope signal misses the trolling motor. When you're mounting the transducer on the transom, basically just use the same standards when mounting any transducer. You want to make sure you've got good clean water coming off the bottom of the boat. Don't mount the transducer in front of a high-speed pickup. Don't mount it next to a chime on the boat. You need good clean water coming over the top of the transducer. We definitely recommend with the shape of the transducer that it's mounted in the forward position to reduce that spray. Speeds, the transducer will basically work great up to around 15 miles an hour. Then you will start to lose some bottom, but we have tested it up to 55 miles an hour, and we did get some reading. Another installation tip is that when you mount the box, make sure you mount it where you can see the status light on the bottom. If you're having trouble with your GLS10 and your LiveScope system and you call the tech line, we're going to ask you what the blink code is or what those blinks are doing in that status indicator box. So we need you to be able to see that box. So make sure you mount it in a position where you can read that. It's also good if you need to unplug that cable, unplug the network port, replace the power cord. I've gotten on boats where this was mounted so tight against the wall that you couldn't even get to it. So it's very important to mount that where you can have access to the bottom of that box, but more importantly, where you can view that status light. So LiveScope is compatible, again, with the 74, 7600s, the 84 and 8600s, the 1042, 1242s, the 1242 touches, the 742s and 942s. They also are compatible with the EchoMap 7 and 9 plus units only, not the CHIRP models. They also will work with the Ultras, the new Ultras 10 and 12 inch. Unfortunately, again, they will not work with the 4, 5, 6, and 7000 series, our legacy series product. So the last transducer I want to talk about is the new LiveScope LVS12. So this was announced in January. Basically, this model has both forward and down built into the unit. No manual adjustment is needed. So forward range is 200 feet as well as 200 feet down. The transducer basically has a 30-degree forward-facing beam as well as a 30-degree downward-facing beam. This unit is compatible with the new EchoMap Ultras 10 and 12 and the GPS Map 8600 XSV chart plotters only, okay? So you can see the LVS32 and the LiveScope system mounts through the network port. The new LVS12 has a 12-pin adapter cable, which connects to the yellow port on back of the unit. So if your unit does not have a yellow port, which if it's not an EchoMap Ultra or the new 86, 10, 12, 16 XSV, it will not have the yellow port. The LVS12 will not work. So comparing the Panoptix LiveScope LVS32 to the LVS12, let's look at the beam angle. So with the LVS32, we talked about you have a 20-degree forward and a 135-degree down. With the LVS12, you still get a 20-degree forward, but you're getting a 30-degree down and a 20 by 30, a 30-degree forward and a 20 by 30-degree down. So you're going to lose, you're going to have some dead space in between those two beams, okay? Maximum range is 200 feet forward and down, and the frequency, again, LiveScope has 3 arrays bursting 530 through 1100 kilohertz. With the LVS12, it has 1 array bursting 530 to 1100 kilohertz. And again, they both have 500 watts of power. So this is basically what the screen's going to look like if you're running an LVS12. You can see the 30-degree forward as well as the 30-degree down, so there will be a gap in between them. And you can look on the bottom of the screen, we've got the GT54 clear view, so the fish that are just coming into the screen on clear view, you can see them are the same fish that are in the center of the screen. So it's pretty important if you want to see both screens on your chart plotter, you can build a custom combo, which will give you a live forward as well as a live down. And here we're going to see if we can play this video. So you can see the trees that are coming across in front of you at 30 feet out. It's going to take a few seconds, and then you'll lose them, and then they'll show up again in your 30-degree cone angle that's going straight down. So, you know, again, this is a $499 transducer, but I've used it, and it's pretty good. I can definitely see fish in front of me, especially, and that's mainly how I fish. I'm looking up under docks. So, you know, it's got great resolution. So let's look at some of the menus and settings. For mitigating noise, the default settings should be adequate in most settings. The noise rejection set to medium should get rid of most of the noise, reduce the shadows generated by stronger returns. The new TVG, which is time variable gain setting, can be used as well. If the bright transmit beams or that sunburst effect you see on the screen are too distracting, we recommend setting them to medium. You also shouldn't experience any interference from any other transducer or trolling motor. Remember, when you want to get into the settings on LiveScope, when you're on your LiveScope screen, hit Menu, and then that'll allow you access into your LiveScope setting. Some other settings. Basically, the orientation. The orientation menu will allow the user to force the mode they prefer, or we recommend using the auto setting. If it's out of the auto setting, you're going to have to manually adjust that transducer forward or down before the unit will read it. We recommend that when you're installing the unit, turn the AHAR sensor. You know, if you're going to calibrate the AHAR sensor, turn the AHARs off completely. Turning off the A-horse allows the user to manually select the installing angle. Again, so if we want to go through this and you want to, oh, sorry, my screen is kind of glitching here. See if I can get off there. If you want to change the transducer angle, you would hit Menu, Sonar Setup, Installation, and then you can go and change the auto, down, or forward. We definitely recommend leave LiveScope in the auto deploy. Oh, sorry about that. Get through here. Oh. So the focus setting is helpful for aligning the beams so there are no splits in the sonar imaging. The type of water that you're using does matter, or the type of water the transducer is in does matter. The auto salt or the auto fresh option should be set appropriately. So to do this, you go into your menu, you go into Sonar Setup, Installation, and then you can set auto fresh, auto salt, and then you do have some fine adjustments that you can do as well. The other feature that you may want to do is you calibrate the compass. I basically use this for the main reason is once you calibrate the compass, you basically know which way that transducer is pointing in the water column. So for me, I'm constantly looking at the screen, and when I'm looking at my trolling motor, I don't know which way that transducer is pointing. So once you calibrate the compass, you'll get this little icon pop up on the screen, and then depending on which way your trolling motor is facing, you'll actually know which way to make that cast. So to do this, you go to your menu, then you go to your Sonar Setup, Installation, Calibrate Compass, and then follow the prompts on the screen. And then once that is complete, that little icon will pop up in the top right corner showing you which way your transducer is pointing. So echo trails. So we've put a trail feature in our radars for a couple years now. So when guys are out fishing, they're looking for birds, and they see birds on their radar, they can actually turn trails on, and it'll leave a little blue line as those birds are moving so you know which way those birds are moving. So we basically did the same thing on LiveScope with fish. So once you find fish, you can turn your trails on, and you can actually see which way those fish are moving. So to do that, you go into your menu, you hit Sonar Setup, Appearance, Trails, and then you can turn them on slow, medium, or fast. I probably recommend starting with slow. So as you can see there, we've got a bunch of fish around that tree, and on the next screen, those fish are actually moving up under the boat. So you can actually follow and see which way those fish are moving. This is very helpful if you're in grass and those fish are going into the grass. Basically, in this amber color, when those fish go into the grass, you lose them. But when you turn echo trails on, you can actually follow the little blue line of those fish moving in the grass. So here's some commonly asked questions. Why can I only see 30 feet forward? Well, you probably have the transducer installed wrong. Remember we were talking about installing it on the barrel and the shaft? Make sure you go back, read those instructions, and make sure you have the orientation correct. The transducer is like a flashlight. If you don't point it forward, it won't see forward. We recommend leaving your sonar setup in the auto position. So if it's left in the auto position, all you need to do is bring your trolling motor up, one click down will then turn the image to the down in the chart plotter. So if you want to go back forward, pull your trolling motor up, one click up, and now you're in the forward mode. So also remember, certain color palettes make LiveScope targets and bottom composition easier or harder to see. So the unit comes default, I believe, on amber. So if you go to menu, sonar setup, appearance, you can actually have these choices for your color scheme. So a lot of people like the black emerald. I prefer going with the blue. For me, on a bright sunny day, I get less glare on the blue screen. Also, larger fish. If I'm seeing bait or a big pot of fish, larger fish show up with a little more red in them. So I can tell if there's large fish down there or if it's just bait, I need to move on. So a couple other things you may want to know about. If you see weird things on the screen, is it normal? Well, a couple of things you can do to get rid of that noise. Set your noise rejection to medium. Turn on auto gain. Set your TVGs to medium if you don't like that starburst effect on the screen. Turn your AHRS on. Set the orientation of LiveScope to automatic. And ensure the transducer is mounted correctly so that cant angle we were talking about is missing that transducer. So what does noise rejection do? When it's off, you get to see most of the raw data coming back on the screen. So low removes the trolling motor noise and interference from other sonars. Medium removes bottom clutter in addition to low settings. And the high setting smooths out the picture and more aggressively hides possible trash and clutter on the screen. So remember a couple of things when installing Panoptix. Make sure if you're going to extend the power cable, use the appropriate wire gauge for the length of the extension. Also, a healthy battery is critical to the performance of the electronics, especially LiveScope. Make sure you know or you have good volts, amp hours, your reserve capacity, and check the load of the battery to make sure everything's working good. Last but not least, I wanted to show you this mount. I get a lot of questions about electric steered, a solution for electric steered motors. These are very popular in saltwater. So there's a couple of manufacturers out there that put this mount out. So you can see the Panoptix is mounted on the bottom of the trolling motor. It comes with a coiled hose to keep your all your cables out of harm's way, and then it has an attachment up top. So that's it for LiveScope and Panoptix. Please, if you have questions, send them to marine.training@garmin.com. Thank you very much.